Alright, hope everyone's going well. We're going to do 3.04 fractional exponents. Alright, and so please take out your notebook and start writing this setup. You can definitely pause the video to do so. So radicand is the quantity under the radical symbol, whereas if here is the radicand is what's inside. The index is the small number to the left of the radical. It is also the degree of the radical. So as if this is the radical, the value would be located right here. And today we're going to be converting between radical and exponents and exponent and radicals. And so what does that look like? Well, we have a base, an index, and a power. And so when we convert to an exponent, we have our base, all power being divided by our index, proving that the index is the denominator, the power is the numerator. So for this example, x to the base, 2 is the numerator, 3 is the denominator, so x to the 2/3, x to the 2/3. And in the reverse, where we have the numerator, x to the numerator divided by the denominator as an exponent, it's going to look as this radical x, whereas the numerator is the power and the denominator is the index. So for this example, we have x to 5 there, 9 there, where it's the 9th root of x to the 5th power. The two things to keep in mind is that if there's no power, like in x, the exponent is 1. So x becomes x to the first power. And if there's no index, the value is 2. Whereas you have something that looks like this, it actually is referenced as a square root. It's because the index is 2. Square root index is 2. And so now we're going to solve x to the 6th power over 9 to the 3/2. And our first step is to distribute the fractional exponent to both numerator and denominator. So this is our fractional exponent, and I'm going to distribute to both terms. And so x over 6 over 9, with the both individually are now going to be raised to 3/2. Second step, On the numerator side, we're going to multiply the exponents because this is product rule, power rule. And the denominator side, we're going to convert the base to radical form. So when I multiply these two, I get x 18 over 2. And when I then operate this whole, I get the cube root of 9 squared. And so now step 3, when it comes to numerator, simplify the exponent. When it comes to the denominator, I'm going to convert radicand to a base where the power equals the index. And so 18 over 2 is going to be 9. And now this 9, I have to think to myself, what times itself? Oh. Shout out to those who've identified. So, see how there's mistakes we can make? That would be there, and that'd be boom. All good at the end. So, what you see is what base times itself 2 times. Because the index is 2, what base squared equals 9. And so if you want to do like the whole algebraic way, you can be x. You don't have to write this stuff down. You square root of x equals 3. Or you can just like think in your head, what times itself 2 times gets us 9. So that's 3. And so, with that being said, e squared and green cubed. Step 4, numerator, just wait, there's nothing more, it's fully simplified. But for the denominator, cancel out like powers. And simplify. And so that 3 cubed, so because the index and that power are both 2, they get canceled out. So I'm left with 3 cubed, which ends becoming 27. So our final answer is x to the 9th. 3 cubed, which means 3 times 3 times 3, 27. And so why do you need both terms to be a fractional exponent? Because both terms need to be a fractional exponent because the values can be operated. Because the whole purpose of this is to have some type of fraction with an exponent that can be simplified into something smaller and more feasible, which is what we have here. Here's all the notes. Thank you so much.